Hello everyone, I'm Georgie, a data analyst from Hungary, and in this project we will have a deep dive into visualizations in Python and specifically with Matplotlib. Matplotlib is an essential library in Python to create some nice visualizations for your reports. We will use many different public datasets to showcase data exploration and plotting, line, bar, scatter plots, and histograms. I will also demonstrate how to customize your plots by modifying colors, labels, legends, and other aesthetic elements. I will be using Anaconda's distribution for Jupyter Notebook, which is what you can see right here, and therefore I will be showing how to install Python, Anaconda, essential libraries, and so on. As you can see from this report, we always start with importing libraries. I will mainly be using pandas and matplotlib, and we will need pandas for basic data manipulation and analysis, and we will need matplotlib for visualizations. As you can see in the second section of this report, I'm using pandas to import a dataset. This dataset is a public Spotify dataset with comma-separated values formats, and I'm using pandas in order to have this read CSV function in order to read the dataset from the path and also set the index from the date column of these datasets and also parse the dates. I will explain what each of these parameters do inside the read CSV function, but at the moment what we can see is basically that we have a data frame which has many different values, but some of them are NaN values, which are basically not a number values, and I will also show you how to deal with this kind of data. In the last section, I have used Matplotlib to visualize the data from the Spotify dataset based on its columns and also added some labels to it. So let's get started. Now, step one, before we go ahead and learn about Matplotlib, is to set up our workspace. There are multiple options when we are working with Python, and the first option would be to install Python through the python.org website. And once it's installed, we can go ahead and write Python code. If you want, you can use Visual Studio Code or other code editors to write Python code and interpret it using the interpreter you just installed. Although this step is optional, because in this project I will be using Anaconda, which is a distribution of the Python and R programming languages. So it already includes Python. It is a perfect choice for data science tasks, so I would definitely recommend installing Anaconda. However, just because it's all about personal preference, I will show you both options. So first is to go to python.org website, go to the downloads page, and here we can see the option to download the latest version for Windows in my case, but you can also install it on Linux, Mac OS, or other operating systems that you are using. So let's click this download button right here, save it, and once the download is complete, you can click this executable, and here we have the setup. So we have an option to have custom installation, or we can have the standard installation. For me, it's upgrade now because I already have Python installed in my workspace. So that's why I see upgrade now right here. But for you, if you don't have any Python installed before, for you it will be install now version, which will basically include all the necessary features that you need in order to have Python up and running. So it is recommended to use the standard version. If you want custom installation, you can also see what are the options for you, like pip, for example, in order to install Python packages. It is also in the standard version. Or you can have some advanced options to, for example, add Python to environment variables or to precompile standard library, choose where you are installing your Python, and so on and so on. But basically, these are dependent on your task, basically, and what you want to do. But always it's recommended to use the standard version. And also, I don't see right here, there should be an option to add Python to path, which is a very important step that you need to do. I don't see it because I have already added Python to the path, but basically it means that our workspace needs to understand what Python means. So when we add Python to the path, we can use Python as a command to run several scripts, which is basically associated to .py files. Okay, so once you install it, then we can confirm that Python is installed. One way is to open a terminal and see the Python version, or we can also see what we installed. just type Python and we can see the base interpreter here. We can open it up. We can see that we have Python 3.11.3, and we can use base operations such as addition, subtraction, multiplication, and so on and so on. We can also use some of the original functions like print function, for example, to print like hello world. So we can see that it's working in the base interpreter, or we can also use it in Visual Studio Code. We can create a new file, choose Python. Let's call it like app.py. Save it. I'm going to save it on desktop. And we can start writing now. So we can have simple print statements here again. Open up terminal in order to run it. And now I'm going to change the directory to where this file is. As you can see, it's in the desktop. So let's change the directory there. And now we can use Python command in order to run this script file. So Python app.py. And now we can see hello world in the output of the terminal. We can also have some complex concepts as well, such as like for loop to basically print out something, say 10 times. So print hello world 10 times. And we can type the same thing. And as you can see, hello world is printed 10 times. Okay, so I showed you basically how you can download, install, and use Python in the base standard way. But now I'm going to show you how to install Anaconda, which, as I mentioned, I will be using for the projects that we are working on. So let's go ahead, type anaconda.com. And we are going to see this download button option. For me, it's on Windows, but you can also download it on Mac OS and Linux. So we just click download, choose where we want to download it. And once the download is complete, you can open up the setup. Basically, I've already downloaded. So let me open it up. Okay, so we have the Anaconda setup. We can click next to continue, agree the statement right here, install it for a current user or for all users. It is recommended to have just for your current user. And then click next. As we can see, the space required for this application is 4.7 gigabytes. So it's a big application, and you can choose the destination folder right here. It's recommended to leave it as it is suggested. I'm not going to click next because I already have Anaconda installed in my environment. So I'm just going to cancel it, but you follow the base standards recommendations for the installation. And once it is done, we can confirm it's by searching for Anaconda. And there are two things that we will be using here, which is Anaconda prompt and Anaconda navigator. So let's open the prompt. Okay, it's right here. And as you can see, we have this base in parentheses, which is basically the environments that you are working on. And first, let's confirm that Python is there. So with Python version. And we can see that Python is there, no problem. We can also see what are the current environments. So for example, this base is where we are currently in, and that's why it has this asterisk sign right here. But there are other environments as well, which are basically environments that include many different packages. Like you usually create new environment when you have a complex project that you're working on and you need many different packages that might conflict with each other if it was in the base. So you create a new one. So for example, if you wanted to create a new environment, you would simply go ahead and type conda create, specify the flag n for the name of the environment. So you can call it like env, for example, or env1. And also includes Python because I want some of the Python packages to be there already when I install this environment. So let's click enter. And we can see that some of the new packages will be installed right here, which is pip in order to install packages, Python, setup tools, SQLite, and so on and so on. So let's click yes. It's gonna take some time. So yeah, now the environment is created, so we can confirm it by conda env list. And as we can see, env1 is right here, but as you can see, the asterisk is still on the base because we haven't really changed our working environment. And in order to do that, we can simply just type conda activate and the name of the environment, which is env1. And now you can see that we have this env1 right here in the parentheses, and we can confirm what are the packages that were installed in this environment. And as you can see, it's only the packages that we installed using Python. All right, so as I mentioned, we are going to use pandas and Matplotlib in this project. So you might also want to install it through conda with conda install pandas. You can also use pip in order to install packages, but I just don't want to have any conflict with the distribution of the packages. So I'm just going to use conda. So I'm not going to click enter because it takes some time in order to install these packages, but you just type this command, proceed, and it's done. And the second one will be matplotlib, but the official syntax for installing matplotlib is this one right here. So conda install, c conda forge, and matplotlib. Sorry. Okay, and once you install these packages, then you're good to go. But you can also use it in the base environment. So I'm just going to deactivate this one because I already have pandas and matplotlib installed in the base environment. So I'm just going to close this and icon the prompt and open the navigator in order to confirm what we have there. Okay, so conda, sorry, it's conda navigator. And this one actually takes some time, probably like 2 to 3 minutes in order to open it up. So let's wait for it. Okay, it's opening up. So we have this, the first thing that we see is basically the environments list. So for example, this is the one that we recently created. We can choose these environments and we will see what applications we have. So we have Dataspell to install. We have VS Code already installed, Datalore, DeepNote, and so on and so on. What we need is Jupyter Notebook. So if you don't have installed Jupyter Notebook, you can just click right here and install it. But I'm going to use base environments where I have already installed Jupyter Notebook. And once it's here, I can just click launch. And let's see what opens up. Okay, I'm going to bring it here. So here we have Jupyter Notebook running on localhost, and we have this tree of directories. Basically, the first thing to do is to maybe create a new folder. So I'm just going to create it in the desktop, new folder. And after that, I'm going to create a new Jupyter Notebook with IPyKernel, which is Python for Jupyter Notebook, basically. And as you can see, it's created already. So we can go ahead to this tab where we have Jupyter Notebook opened up. And what we can see here is that we have some of the code cells that we can use in order to write the code. So it's not like in, for example, in Visual Studio Code, when we created this .py script file, it's not the same. Here, each code cell runs independently. So for example, if I wanted to use like print statement here, the output is only for this first line. And then I'm going to write a different line right here. It's going to be completely different and independent cell output, let's say it like that. So Once it is done, so once we have created this notebook, then we can use pandas and matplotlib to confirm that we actually correctly installed these packages. So the first thing to do is to import pandas into our workspace. So I'm going to use this import keyword, import pandas. Okay, this is enough to write it like that, but sometimes and usually people prefer to have some like shorter keyword for the actual pandas, so they usually write it like this. So import pandas as PD. So next time when you're going to use pandas in order to run some functions on it, then you're going to use PD dot and whatever the function is. Okay, and for example, in order to confirm that this is working, first run this cell in order to import pandas into our workspace. So no errors. We can see this 2 right here, which is the second cell runtime, let's say it like that. And after that, we can confirm that this pandas is working by typing pd dot, for example, the data frame function that basically creates pandas data frame out of the dictionary. So in this dictionary, we are going to specify some key and a set of values. And once it is done, we can see that data frame is created already, so pandas is imported correctly. We can also import Matplotlib, which we can do by import matplotlib.pyplots. This is the way that we import Matplotlib into our workspace, and we can also have shorter form for this one to import it as plt, for example. We can run it and confirm. Yes, it was already imported, no errors. So here we can actually create some set of values in order to have some visualization, like X, for example, to be a list of some values, and the same for Y. And let's save these variables by clicking Control and Enter, by the way. This is the way you run the cell. You can either run it from here, or you can use Control Enter or Shift Enter if you would like to go to the next cell after you run it. So Shift Enter, if you click that, you go to the next line. But with Control Enter, you stay here. But it doesn't really matter at this point which one would you use. So I'm going to use this plt.plot function in order to plot x and y variables, in this case the list of values, and then use plt.show function in order to actually show the graph. Okay, so we can confirm that the visualization is there. So both pandas and matplotlib were correctly imported into our workspace, and now we can start the project. So we can continue our project and start with the first step, which is data exploration. And the first thing I would like to mention before I go ahead and load the dataset is that if you would like to have your Jupyter Notebook reports more presentable to the audience, you should actually use Markdown cells. And Markdown is actually a pretty easy syntax. If you would like to create some headings or paragraphs or things like that, you can go to Google, search Markdown syntax, and you will find the actual way to write Markdown. So if we would like to have heading 1, for example, we are going to specify the hashtag, space, and whatever the heading is. And then we're going to click Control Enter to actually run this Markdown cell, and we can see that we have a heading. Okay, so the first step is to actually import pandas, because we're going to use pandas to load the dataset and to explore some of the cool insights from the dataset. So let's import it. Import pandas as PD. Click Shift Enter to go to the next line after running this one. Okay, and the next part is actually to load the dataset, but where do we search for public datasets? And the source is basically kaggle.com. You go to the datasets page and search for whatever the data you would like to have. And there are many different data sets for a variety of tasks. And for this project, for data exploration, I have chosen this IMDb 5000 movie data sets. And we can scroll down and we can see the actual data set right here, movie metadata.csv. We can simply click this download button right here and save it wherever we want. And it is most probably going to be an archive, and we just unarchive our downloaded file, and we will see this CSV file right there. Okay, so I have saved these data sets inside the src folder of this directory. So I'm just going to create a variable that will basically save this data frame, and then going to use read CSV function in order to import the dataset. So I'm going to specify the path where this data is. And what you see right here, these two dots and slash is basically a relative path, which specifies that we are going one directory up in the hierarchy. So for example, if we had one dot in the relative path, it represents the current directory, and two dot represents one up in the hierarchy. And we can specify the path. For me, it's in src movie metadata.csv. And after that, we can simply just type movies in order to print the actual data set. But there's also another function that is only printing out the first 5 rows, which is head function. And after we run it, we can see that we only have 5 rows here. Many different columns. As we can see here, it's 28 columns. Or we can specify any number of rows that we would like to have, like 10 rows, for example. Okay, and after we do that, the first thing that we need to inspect is basically what is the shape of this data frame that we just imported. And the shape is basically the number of rows and number of columns. So we're just going to type movies, which is the data frame name, and then shape attributes. And here we can see that we have 5,043 rows and 28 columns. Okay, so what is the data frame? Basically, this data frame is a collection of many different series, and the series are basically the columns such as like color, director name, and so on and so on. And if we would like to print out a specific rows based on column, like for example, the column director name, what we need to do in order to access this series is by typing movies dot in order to access columns series, and then type the name of the series. So in our case, it's director name, this column right here. After we run it, we get the rows based on the column director name. We can see what the name of the series is, what is the length of it, and what is the data type. The data type is specified as object, which is basically string object. There is another way that we can access the series, which is by using these square brackets and typing the name of the series inside quotes. So director name. And we get the same output. And the way and the reason why people use these square brackets and quotes is that sometimes the column name includes spaces. Not in here, but there are some data frames which might include spaces. And if we include space right here, there would be no output basically. So it is sometimes recommended to use the square brackets. Okay, the next step that I would like to check is the actual data types of each series in our data frame to see basically if the data types are correct. So we are going to type the data frame name, and the types is an attribute that we are looking for in order to check what is the data type. Okay, and we can see these 28 columns with their data types. Like for example, the color series is an object, so a string. The name of the directory is an object. The number of critic for reviews is float data type. We also have integer data types. And from here, we can inspect that actually all of these columns have correct data types. So we don't actually need to modify anything here. But we need to check for NaN values, so for the null values, because as we can see from here, there are some NaN values, like for example here, here. There are many NaN values. This is only 10 rows, but if we actually mm, run the whole data frame, we can see that there are other NaN values as well, and we need to solve this issue because when we try to work on this type of data, we might have some conflicts with the results. So first of all, let's check how many null values we have. And the function that checks that is actually isNull function or isNA. They basically do the same thing. And if we run this, we can see that it returns Boolean values, either false or true, which represents that for each column, for that row, if there exists a null value or not. What we can do is to sum up these values, and we can see how many null values are there in each column. Okay, so we can actually see that, for example, in gross, we have the most number of null values. What we can also check, and the main question that I had is basically how many columns have null values. So here we can either count it by ourselves. We can see that there are some columns with zero number of null values. So we can actually have a logical operation here. So to check if the left side, what we have written here is more than zero. And if it is more than zero, like we can see that these columns are true, so they actually have null values in them, and we have false values for those that don't have it. What we can do is then sum up these again, so that we get the sum of true values, basically. And if we run this, we're going to get 21 as the output. So 21 columns out of 28 columns have null values in them. And that's, well, not the best thing, right? So we need to either remove these rows where we have null values or fill these null values with something. However, depending on your task, you might not actually need some of the columns. So for example, for these projects, I want to mostly be analyzing the movies with respect to the ratings, cross-collection, popularity of movies, etc. And so many of these columns that we have in this data frame are not actually required. Like for example, the color or director Facebook likes or actor one Facebook likes and stuff like that. So for example, if we can check actually what are the value counts for a specific column, like for example, colors. And we can have this function value counts that basically checks the frequency of the values that are in our column. Sorry, it's not colors, but the name of the column is color. Okay, so we can see that in colors we have basically two values, which is color movies and black and white movies. And we can see that most of the values, like the high frequency values, are colors. So we might not actually need this one. And as I mentioned, I want mostly to be working with movies with respect to the ratings, cross collection, and so on and so on. So I don't actually need this column and some of the other ones as well. So the way that we drop columns is first by kind of like manipulating the variable of movies. So saving new values to this movies data frame. And the function that we are looking for is drop function. And inside this drop function, we can actually specify the list of columns that we would like to drop. So I'm going to copy and paste the columns that I don't really need. So color, director, Facebook likes, and so on and so on. But what we also need to specify here is the axis. And the axis parameter actually specifies either 0 or 1. If we write 0, it means that we are removing the rows. And if we write 1, it means that we are removing the columns. And that's what I actually need. So let's run this cell. And now we can check the columns from this movies data frame, and we can see if they were actually removed or not. Like for example, we can run this cell again, and as you can see, we are left with less number of columns. So some of them were removed, the ones that we don't need, and we can actually run the shape attribute in order to see how many were removed. So we are now left with 13 columns only, and that's the one that I basically need. I don't need anything else, but if we inspect the null values, so movies is null and some function over that, we can see from these columns that there are still some columns that have null values inside them. And the thing is, where we have the less number of NA values, we can actually drop these rows. Like for example, the one where we have across like 800 NA values, we don't actually drop these rows because it actually represents some important values. And we can't actually modify and write 100 rows for director names because we don't actually know who the director is. So for this type of data, we actually need to drop these rows. So we use the drop function, but in this case, we are using drop NA function, which specifies that where the NaN values are to drop those rows. And in here, we actually need to specify the axis to be 0 because we actually want to remove the rows and not the columns. And we can actually specify the subset as well. So I'm going to copy paste here. So from these columns like director name, num-critic for reviews, actor one name, num-user for reviews, and language, these are the ones that we can't really modify. So I'm just going to drop these rows basically. And before, the way that I manipulated this movies data frame is by typing this movies equals again, because I wanted to apply these changes to the movies data frame. But if I don't write it, it will only be run for this current cell and it will not be applied to the following cells. So there is actually another way that we can apply these changes by typing the in place parameter and assigning the value true to it. So all of these changes that we do here in this cell will take in place for the movies data frame. Okay, and now we can check these null values again. And as you can see, the null values were removed, and now we are only left with gross and budget. Okay, so now what we can do with this gross and budget is that we can't really remove all of these rows because it's many number of rows. What we can do is to use fill NA function. So I'm going to type it here. Sorry. So we first want to modify budget. Use fill NA function in order to fill with something. So in order to apply some different values to those NaN values, right? And what can we do inside this parenthesis is that we can specify what we are filling it with. So one logical answer to it is to have some descriptive statistics applied to it. For example, we can have the average of the budget column and apply that average to the NaN values. But I believe that at this point, median is the one we're looking for, which is the midpoint of these budgets column. So we are just going to specify the column again. So budgets and type dot so that we can access a specific function. And this function is called median from the descriptive statistics. And we can also write in place through here so that we don't have to write like movies budget equals movies budget dot fill and so on and so on. So we to not be too repetitive basically. And we can do the same for the gross as well. So it just repeats the same steps. Apply the median and in place equals true. Okay, we got no errors. That's good. Now we can check for these null values. And as you can see, we don't have any null values anymore. So we finished the data cleaning part. Now we can see like what is our current shape. So write the shape again. So we have 4,879 rows, which is not that bad. We haven't removed many rows. We only removed the ones that we didn't really need. And now we are good to go to have some like descriptive statistics applied to this data frame. And by that, I mean like mean value, standard deviation, count of the values, and stuff like that. We don't actually need to write them one by one, such as like movies, mean, STD, or stuff like that. There is a function called describe, which includes all of these descriptive statistics. And if we run it, we can see for each column, what is the count of the values, what is the mean, what is the standard deviation, what is the minimum value, 25th percentile, 50th percentile, 75th percentile, what is the max value, and these are the base descriptive statistics. And sometimes you may actually have many different columns, like huge number of columns. So you have to scroll to the right to actually see what are the columns and values. So it's we can actually apply the transpose to it by typing dot and t, and with transpose the index and the column is basically going to change their places. So we can see here that now the columns are the actual statistic names, and for the index we have the name of the columns. So it's more presentable, let's say it like that. Now, one thing that I also saw in the data frame is that, let's scroll up a bit. And for gross and budget, we have the values in like values that are like really big, mostly millions, for the gross and for the budget as well. So it is actually quite logical to convert these values, to convert their units of the budget and gross columns from the dollar to the $1,000,000. So like if we have, let's say, $715 million inside gross or budget, we would present them as 750. Okay, so let's scroll down and let's do the conversion. Okay, so, and the way we do it is manipulating the specific column. So let's type budget first, selects these values from the budget and divides each and every row by 1 million. Is it 6 zeros? Yes. And do the same for gross. So movies gross divided by 1 million here as well. Okay, and after we do that, we get no error, and we can run this head again to get the first 5 values, let's say. And we can see that for 760 million, we presented it as 760 and so on. So the unit is basically more presentable this way. Okay, so what is the next step? A very cool thing that we can do with data frames using pandas is that we can actually create new series as well, so new columns. So we, for example, the only thing that we need to do is to specify the name. Sorry for that. So the only thing that we need to do is to specify the name of the column that is not already there in the data frame. So something like profit, for example. And I would like to calculate the profit for each movie, for example, right? And the way I would do that is by subtracting gross and budget. So I'm going to select the values from gross, subtract values from the budget. And that way we are going to get profit for each movie. Okay, let's run this, no errors. And the questions that we can answer with this profit column is to basically, for example, sort the values based on their profit. So the way we can do that is by using sort values function. We have to specify what are we sorting them by. So we are sorting them by profit. column, and I would also like to specify one more parameter, which is ascending parameter, to be equal to false because I want the values to be descending. Okay. And this way we get like top movies that had, let's say, highest profits. Like, for example, $523 million was for the movie Avatar by James Cameron. Okay. We can also specify, let's say, the top 10 movies based on their profits. We only get 10 rows here. Okay, so that's a good thing that we can do. And there's also a concept of searching specific rows based on a condition. So for example, let's say I would like to get all of the rows, so all of the movies where, let's say, Leonardo DiCaprio was starring in it. Let's call the variable Leo and use the lock attribute, which is basically locating specific records based on a condition. And this condition in this case would be the actor one name. That's the person who is starring in the movie. And to have the double equal sign that will basically have the logical operation inside the condition. So check the left side and the right side and return either true or false. And once they are true, you locate these records with log to actually retrieve the records themselves and not just true and false values, right? So we specify the name of the actor. So Leonardo DiCaprio, and then we can print the output by typing the name of the variable. Actor one name. Maybe it's something different. Oh, sorry. It should be not actor, not ecator. So my bad. And now we get all the movies where Leonardo DiCaprio was starring in it. So Titanic, The Great Gatsby, Inception, and so on and so on. So these are the basic steps that we can do in order to explore our data using pandas. And now we can move on and continue to the visualizing parts of this project. So let's continue our projects. And now I'm going to explain line plots. And for this, I will be using a different data set because line plots are actually best for showcasing trends and patterns over time. So let's use a different data set. I'm going to be using Spotify.csv dataset. You can download this dataset by clicking this download button right here. And I'm also going to paste the link to the dataset right here. And I'm going to start by importing the libraries, pandas, SPD, and Matplotlib. Okay, maybe yeah, I have a syntax error right here. It's okay. And after that, I can import the data sets. I'm going to call the variable df, which stands for the data frame, because after importing the data sets through pandas, it will be transformed as a data frame. So pd.readcsv. After that, I'm going to specify the path. And then print the last 5 rows from the data set, because if you remember, using the heads, we didn't really have much information in the first 5 rows. So we can output the last 5 rows by the tail function. So now we have more data to showcase basically. And let's also inspect the data types of these columns. df.dtypes. And as you can see, we have date column as an object, so as a string. We have the first song shape of you as integer and the rest of the songs as floats. So it's not a big deal if shape of you is an integer and the rest of the songs are in floats because they are still numerical values and we wouldn't have too big difference if we converted the rest of them in integers or shape of view in floats. But we need to deal with this date as object because it's always better to have appropriate data types for the records. And the way to do that is by parsing the dates. So we can either set parse dates to true. So let's inspect the data types one more time. And as you can see, the date is still an object. And the reason behind it is that Pandas sometimes doesn't really understand which column or which values to take as dates, as it is present as strings. So sometimes we actually have to specify what the column is, basically the column that has dates in it. So we are going to specify the column, which in our case is called date. And after that, we can see that it's in datetime format, so we're good to go. And also one more thing that I would like to do is to set date as the index for these records because we are trying to show the trend over time, and it is mostly logical to use date as an index and not some random values, basically. So let's set index column to date. And after that, you can see that the indices are dates, basically. So now we can move on and actually visualize our data. And what we need for that is plt.plot function and specify our data frame. That's the only line of code that we need in order to have a basic visualization. And with this plt.plot, we actually save this plot inside the memory and also represents the graph. But sometimes, depending on the environment you're using, you might not get the graph and you might only get this memory output right here. So that's why we usually use plt.show in order to showcase the graph. And here we have no memory output, just the visualization. Okay, so, but this is just a basic representation. We can go a bit deeper. Like, for example, we can set the size of the figure. And for that, we basically need the figure function. Inside the parameter, we specify the figure size. And the figure size is basically width and height of the graph in inches. So for example, we can specify 14-inch width and 6 inches height. Okay, it's a bigger visualization. We can see a bit better. Now, another important thing to showcase is also the labels and title of the visualization. There's none right now. So what we can do in order to do that is firstly to use the title function so that we can set the title for the visualization. Something like music trends on Spotify over time. Now we have the title. We can also set the X label and Y label in our graph, such as not equality, but in the parentheses, as it's a function. Okay, so date and values as X and Y labels. Okay, now we can see that we have all three of them, the X label, Y label, and the title of the visualization. Now, we can also specify something called a legend, which basically associates the line to the column, because from this graph, we can't really tell which song we are seeing, right? We can only see some lines. So if we specify the legend and also write in the parentheses the data frame where the columns are coming from, which is df in our case, and run the code, now we can see each color of the line associated to each column from our data frame. Okay, so we are good now. Another thing which is completely optional is to add a grid. For example, plt.grid set to true, and now we have the grid in our visualization. What we can also add is basically the units for the values that we are seeing right here. So as we can see from the data frame, we have the values in million units, like for example here, 4 million, 3 million, 2 million, and so on and so on. And here we can see 2.0, 1.5, 1. And the thing is that for a person who has never seen the data sets, it might be a bit of ambiguous of what these values represent. So we can actually leave these values in its original format, okay? And the way to do that is by setting the tick label format function, choose the axis in the parameters. So we want to deal with the axis Y in this case, and set the style to plain. And after that, we get the values in their original formats. So now we are almost ready to go, basically. What we can also do in Matplotlib is to have some kind of conditions in order to represent different parts of the data. Like one option is to not specify the whole data frame, like each and every column that there exists, but only a specific song in our case. And we can specify that in the plt.plot function. Now we are passing in the whole data frame, but we can also pass a specific column, like for example, only shape of you. And that way we only get one column represented in our graph. Now there are some additional parameters inside the plot function, such as marker, which basically specifies kind of like a symbol for data points. I'm going to specify O, which basically is it's like a dot or a circle kind of notation for the data points. I can also specify the line style, like dash line, for example, and a color of the line to be red, and R specifies that. And you can look up these exact parameters and what options you have on Matplotlib official documentation websites, and then you can see exactly what are the options that you have. Okay, let's run this code. Now you can see that we have marker for data points. We have the line style of dash because that is basically the line. Although we can also specify like 2 dashes. Now we have kind of like a dashed lines. And we can also specify another column inside the same figure by using the plt.plot function again, specifying a different column like the second sum, for example. We can have a different marker. There's also S marker, which you will see what it represents. We can have a different line style, just one dash, and color to be blue, and B represents that. So now we have only 2 columns represented in our visualization. We can go a bit deeper by only specifying certain data points over time. And the way to do that is to kind of like create, let's say, 2 variables. So like the start date and end date. For example, I would like to start from 2018, 0102. Because as you can see here in this graph, we only have like a single year, like from 2017 to 2018. We don't really have any graph that specifies from 2018. So we can do that, and the end date to be like 2018, 0108, let's say. After that, let's create a new data frame that will represent these data points. So let's call it df selected and use df lock in order to locate our data records based on a specific range or condition. And here we can specify the range of start date and end date. And the way we do that is by using these two variables and using colon that specifies the range in Python, basically. So start date and end date. Okay. After that, we can print out our data frame. So let's see what we have. And as you can see now, we have the data points starting from 2018 0102 up until 2018 0108. Okay, and now we can plot this figure, okay? And the way to do that, first let's set the figure size again for this new visualization to be the same, 14.6. After that, use plot function and specify the data frame. So this new data frame. Also take the legend so that we know which songs we are dealing with. We can also set this peak label as well so that we have the data points in their original form. And then simply just plt.show. Okay, so now we have created visualizations based on specific conditions like date range or specific columns. And one last thing that I would like to mention, something that we can do with Matplotlib, is basically using the templates for the graphs. And the way that we do that is firstly by inspecting what are the available templates. So we can print plt.style.available. So we can see there are multiple templates available for us, and we can choose, for example, this BMH template for our graph, and the command is pretty simple: plt dot style dot use and the name of the template. Time maybe, yeah. So now we have this type of templates that is present in our visualization. So that's about it for the basics of line plot in Matplotlib. And now we can continue our projects with different types of plots, such as bar plots. All right, so for bar plots, I'm going to be using another data set, which is called telco customer churn. And in this data card, you can basically see what this data set is about. We can see that the content of the data sets specifies as each row represents a customer, each column contains customers' attributes described on the column metadata. And we know that the main targets variable here is churn, because these are the customers who left within the last month. And the basic context about this data set is to predict the behavior to retain the customers. Now, that's not what we will be doing in this project because that's a bit of a machine learning task, but we will be describing basically how bar plots can be used to represent some of the data included in this data set. Okay, so I'm going to be using another library other than pandas and matplotlib right now. It's called NumPy. And NumPy is basically a library for Python, which basically adds support for large and multi-dimensional arrays and matrices. And the reason we need this, I'm going to showcase it later. Okay, so here is the link to the data sets. After that, I import it with pandas using read CSV function and show the first 5 rows of this data set. And this is basically what we have. So churn is the one that we are interested in. This is the target variable basically. And the first thing that I usually do when importing a data set is to inspect its data types, right? So let's type df dtypes. And here we can see while most of the columns are in correct data types. But what I can see from here is the total charges, which is an object. So it is a string. And if we actually look at the column total charges, we can see that it actually represents numerical values. So it's something that needs to be modified. And the reason I am actually modifying these columns is because of the following reasons. So let's use dfdescribe first in order to get some basic statistics of the numerical columns. So the only numerical columns are senior citizen, tenor, and monthly charges. Okay, and let's check if there are any null values. So df.is null or is na, and use some function over it to get the actual values. Not attribute, but function. So yeah, there are no null values here, but we have one column, which is total charges, that is represented as an object, as a string. So we might not actually know if it includes any null values or not. So first, we need to convert these total charges into a numeric value and then check again if there are any null values. So the way that we convert a column is by first typing the column name itself, so total charges, then using the function from pandas called toNumeric and indicating which um, column we will be using in order to convert inside this function, and it's total charges again. And we also need to specify one more parameter, which is errors, and set it to coerce. And the reason I'm doing this is because in this toNumeric function, we have this parameter called errors, which has the default value of raise, which means that then invalid parsing will raise an exception. If it is coerced, then invalid parsing will be set as NaN, so null values. If ignored, then invalid parsing will return the input. And what we want is to set all the invalid parsing in NaN, so in null values. So that's why I'm going to be using coerce. Okay, and after we do that, we can actually inspect this is null again on a different cell. Keep forgetting these parentheses. Okay, and now you can see we have some null values in total charges. So it's not too much, it's just 11, so we might actually not even need to do anything about it. We can actually locate these 11 values with lock and then indicating what the column is. It's from the df total charges. And then we specify the condition here, not a range, but a condition. So the condition is if if in total charges there is a null value, then locate those values, right? So we need to type this kind of condition inside the square brackets right now. So is null, double equality for the logical condition and equality to true. So that way we are going to get all the null values, the records themselves. So here are the rows that have these NaN values. And as you can see, here are the total charges, NaNs. Okay, and these customers are not charting, so none of them. So we might actually leave these as is. And now we can use the dfdescribe to confirm that we have another numerical value, which is total charges. We can also look up the data types again. And total charges is now float data type. Okay, now we move to actual plotting parts. And there are multiple ways that we can use bar plots. So I'm going to start with only using Matplotlib. So I'm going to create a new variable, which is I'm going to call it charn counts. And I'm going to set the charn column here and count its values. And by count its values, I mean to see what unique values we have and what is the frequency of them. So that's what we will showcase in the bar plot. And after we have these values, we are going to use plt.bar function. That's how we plot the bar. And afterwards, we need to set two parameters, which is basically like x and y axis. And what do we need to set as x and y here? So we want the values to be present on the y-axis because we want to um, show basically in a normal way, basically what the bar is. And on the index, on the x-axis, basically, we need to have the values, the unique values that is present in the charn column. So I'm going to set from charn counts. This is the variable that I currently saved, and the value of it is value counts. So I'm going to get index as as an x-axis, and I'm going to get the values, so the actual value counts for the y-axis. Okay, after we do that, I'm going to put some x label and y label as well. This is optional part, but it's always recommended. So x as count. I'm sorry. So for x, we need something like target variable because we have the counts on the y-axis. So we need y label for that and call it count. Okay, and here we have our first bar plot. From the charn column, we have either yes or no records, and we are basically counting how many yes and how many no records we have in the data set, okay? And as I said, there are multiple ways that we can use the bar plot, so I'm going to use another way as well. And this way is using Matplotlib and pandas plot at the same time. So here we used pandas function for counting the values, but now I'm actually going to use the pandas function for plotting and then setting some of the labels and titles using Matplotlib. So I'm going to do the same thing here as I did before. So select charn and count its values. And then there is a function called plot, which actually comes from pandas. And we need to specify here what is the kind, so what kind of plot we want. In this case, we want bar plot. And we can also set the figure size, something like 8:6. And after that, I'm going to use Matplotlib to set the titles and the labels. So the title to be something like count of target variable per category. Also set x label and y label. So x to be the target variable and y label to be the count. Okay, it's the same kind of graph, same kind of visualization that we have here, but I'm here basically to show you both ways. Okay, so now I would like to talk about why I imported NumPy. So what's the reason for that? And the reason is that sometimes we would like to create correlation matrices in regards to the target variable. And our target variable, which is char, is actually an object. It is a string. So we can't really create a correlation matrix out of an object, right? So what we need to do is to convert char into a numerical value. But how do we do that? We only have no and yes in char, right? So we might convert it into numerical by specifying that yes is 1 and no is 0, something like that. And NumPy helps us with that. NumPy helps us return the elements chosen from X or Y depending on the condition. So we specify the condition and then it returns those elements. Okay, and then we can like save those elements and kind of like update our column. Okay, so in order to update the column, we need to create a new variable, not new, but in this case, just df churn so that it gets updated. And after that, I'm going to use numpy. So I have imported it as np, and the function is called where, and then we specify the condition. So in the condition, I basically write that df churn, or you can also write it like this. So df churn logical condition, if it is equal to yes, then we set it as 1. Otherwise, we set it as 0. So these are the parameters that we can set in the where function of numpy. Okay, after we run that, then we can inspect our records by printing out the first 5 rows. And let's see. Okay, so churn is now zeros and ones. So we have converted it into numerical values. Okay, now let's build a correlation matrix so that we can represent this correlation matrix in a bar plot. So the function for that comes from pandas, which is core function, stands for correlation. And we want to build this correlation in regards to the target variable, which is churn. And we also want to kind of like sort the values so that we get the values in a sorted way, let's call it like that, because in a bar plot it would look better. We can skip this part as well. I can show you like both ways. So if I just run this, we have the correlations, but it starts from like senior citizen column 0.15, tenor like minus 0.35, stuff like that. So if we actually sort these values, then we would have a better graph, let's call it like that. So if we sort the values and indicates that ascending parameter to false, so that we get values in descending way. And now it looks better. So it starts with churn, obviously churn to char is 1. Then monthly charges. So it is sorted descending values basically. Okay, after that, I'm going to specify the figure size using Matplotlib. So the fixed size is maybe like 22.8. And after that, I'm going to use this one again. And use the way that we did before using pandas plot, kind bar, and sorry, I had the syntax error here, size. And it needs to be equality. It's not a function, it's a parameter. Okay, and now we have the bar plots for all the predictors. And now I can also do it with Matplotlib. So not with pandas plot. First, I'm going to specify the figure size again. Fixed size. Let's do the same. 22.8. And after that, I'm going to save this one into a variable because we need to get index and values. So let's call it something like churn or. And then I'm going to use Matplotlib's bar function and use the index of this variable on the y-axis, sorry, on the x-axis, and use the values for the y-axis. So let's run this and we have the same output. So these are the basics of bar plots using Matplotlib, and I'm actually going to leave this data set because this telco churn, customer churn data set actually has many different types of data that we can represent in many ways. So let's continue. All right, so now let's talk about scatter plots. So scatter plots are a type of visualizations that basically show the relationships between two variables. And these variables can be, for example, from our data sets, tenor and monthly charges. Okay, so let's create like X and Y variable so that we don't have to repeat the names of the columns many times. So X is equal to df tenor and Y is equal to df monthly charges. And after that, the function is very simple. We're just going to write plt.scatter X and Y. And we have the plots. Or we can just add like plt.show. So here is the relationship between tenor and monthly charges. Although we can see the relationship between these two variables based on the values that we can see here. However, we can't really tell much from these kind of plots. I mean, it needs to be presentable to the audience so that they or we also understand what's going on with this data. So just because the data here, the data points are really complex, I'm going to create a function that will have basically different colors on the points based on like if the customer churned or didn't churn, for example. We can differentiate it based on that. And we can also add some title, labels, legend, and so on and so on, so that it is actual presentable plot. So let's start by defining the function. Let's call it plot pair. We're going to pass the arguments data, which is going to be the columns that we will represent, the X feature and the Y feature. That's what we are going to use as like two variables basically to differentiate, and title of the graph as well. Like we can like change it based on like what our needs are. And at the initial step, we're going to call it none, but then it will be modified after we call it. Okay, so let's write the body of the function. So at the first step, I'm going to set the figure size. So it's going to be, there are a lot of data points, so the figure size needs to be a bit bigger than this one that we have right here. So maybe like 12 to 8. After that, I'm going to differentiate and separate the data points based on the churn column. So either like 1 or 0 as we have right now. So the churn data, let's call it like that, this variable, and take the data from our data frame from the column churn and basically create a logical condition there. So if it is 1, so if the customer churned, then we will save it in the variable churn data. And if the customer didn't churn, let's call it like no churn data, then we're going to create a logical condition where the churn is basically 0. So these are the only two values that we have, right? Okay, and then we are going to use the scatter function from Matplotlib, so plt.scatter. And here we need to insert these X and Y features. So not directly X feature and Y feature because these features are going to be the names of the column. So in order to actually represent the data, we need to input as inside the square brackets of the data frame. So that's how we represent the actual series, right? So let's input these series right here. Churn data X feature, churn data with Y feature. We can also specify the color. Can have the customers who churned in the color red. And we can also give a label parameter. So these are the customers who churn, so that when we use the legend function, these kind of like titles will be based on these labels, right? Okay, then we are going to plot non-churned customers. So let's take this not churn data variable, pass the same X feature and Y feature. Okay, let's represent it with a different color, so maybe blue, and give it a label as well as not charmed. Okay. After that, we give some like titles, X, Y labels, and so on, like the general steps. So the title is the title that is passed inside our function. And we can also set the font size of the title. Let's make it bigger. And then the X label, which is the feature that is being passed as X. Sorry. So it's going to be the X feature. The Y label is going to be Y feature. We're also going to show the legend based on the labels that we have specified here using parentheses. And after that, simply just use the show function to display our graph. Okay, so the function is created. Now let's use this function to feed in some of the data that we want. So let's call it like create a new variable with scatter data where we are going to get some of the columns that we are interested in, basically. So we are interested in tenor. We are interested in monthly charges. And we are also interested in churn. So these are the columns that we're interested in to basically showcase in the scatter plots. Let's use a new cell, and now let's use our function, this plot pair function, and feed in the data first, because that's the first parameter that we should put in. So scatter data. Then we are inputting X feature, and our X feature should be tenor. Our Y feature should be monthly charges. And the title to be something like reasonable title, like tenor versus monthly charges. Okay. And now we have way better representation, but let me open this in a new tab so that we can see it properly. So this is the graph that we basically wanted to compare these two variables, like tenor and monthly charges, based on like if the customers were charged or not. So this is what scatter plots shows us. And now we can move to the histograms. All right, so histograms are a type of graphs that shows the frequency of the numerical data where the height of the rectangle that is present in the visualization basically represents the distribution frequency of a specific variable. So the amount or how often that variable appears. And in Matplotlib, we can do this with a function called plt.hist. And let's start. So plt.hist, and inside the parameter, we need to specify the variable x. And this variable x is basically what are we trying to represent. So the numerical variable that we want the distribution for. For example, we can have it for a series called tenor. We can also include the number of bins. So how wide do we want the distribution to be, basically? Let's give 10 bins. And we might also have edge color parameter, which is kind of like a border edge for those bins. And it can be black. We can give some X label, such as tenor, Y label as frequency. Then we might give some title as well, such as distribution of tenor and plt.show. And this is the histogram that we just got. We can also add a grid to look better. And this is what we have. And when I mentioned about bins is basically we can have higher number of bins, and you can see what kind of distribution that we have. If it is smaller, then there's smaller amount of bins basically. Okay, so let's leave it at 10. We might actually have the range of the values as well. So for example, right now we can see that with the full distribution, the minimum value is 0 and the maximum is like more than 70, like around 72, 73. And we might need to have a specific range where the values are starting from, let's say, from 10 to 34. Um, I missed comma here. And now we have from 10 to 34. But at the moment, we can just leave it as it is to have the full distribution of this variable. And we can go even a bit deeper with this histogram as well. For example, we can choose this distribution of this variable based on a target variable. And in our case, the target variable is churn. So we can choose if the customers are churning or not, and what is the tenure value, appropriate value for that. So we can create like two variables like we did before, like tenure, churn, no. So the customers who are not churning, and we can specify the condition inside the square brackets for that. So df.churn and logical condition to 0, and then dot tenor. So this dot tenor will, after the condition is completed and we get the actual values, then it will kind of like assign the appropriate values for tenor and return the series of tenor for customers who didn't churn. So this is what we are saving in this variable. So we're going to need another variable, which is going to be the exact opposite. So if it is equal to 1 and tenor. Okay, afterwards, we're going to use the histogram function and include kind of like list of variables that we would like to present. And in this list, in the square brackets, I'm going to type these two variables that we created. So tenor churn yes, and tenor churn no. We can also include in the parameters the color of the bins, and we can differentiate these two variables basically. So the first color that we write inside this list is going to be for the customers who churned, and the second color will be for the customers who didn't churn. So who churned, it's going to be red, and who didn't churn, it's going to be green. Okay. And if we want to include the legend in our visualization, that it's also better to include the label as a list again, because we are doing it for the both. So the first is going to be churned and not churned as we did before. And now we can add some labels, the general steps. So the X, on the X label, we are representing the tenor. On Y label, we are representing the frequency of tenor. So we can just write it as number of customers who are in those range of tenor. Then we can come up with a nice title, such as like customer churn prediction. We might add some grids, the legend for the labels, and show. Okay, and now we have a bit deeper analysis of what's going on with the distribution of the tenor. So in several ranges, like for example, from when the tenor is 0 to approximately like 4, then the customers are churning. When it's from let's say 4 to 6, then they are not churned, and so on and so on. So we can represent the distribution of a specific variable based on the another series, let's say, in our data frame. And it's not as much as prediction, but we can tell from what kind of information from tenor the customers are churning, basically. So based on what? So these are the basics about histograms, and we have successfully completed this project. So to sum up everything, in this project, I have shown you how to set up your workspace, import and explore your data to find some interesting insights. I have also demonstrated how to use different kinds of visualizations in Matplotlib and in what cases we need to use them. I encourage you to explore more about types of visualizations in Matplotlib and inspect its parameters for the best approach. You can also create your own projects with the available public datasets on Kaggle. You can just go to the Kaggle website, choose the dataset, read the data card to see what is there to explore, and use the knowledge you gained from these projects. Thank you and keep it up.